Let's consider now the different modes of heat transfer. The first mechanism we'll start with is that of conduction. This is heat flow through a stationary medium. This means that there is no flow, so we can temporarily turn off fluid mechanics for this mechanism. Imagine this in the case of a window pane on a hot summer day. It's really hot outside, and yet it's cooler inside. And if I go up and place my palm against this window, I'll feel that heat conducting through the glass. That heat transfer is depicted by this green arrow. In general, conduction is mediated by molecular collisions in a fluid or a gas. These are gas molecules, for instance, that are running into each other and thereby transferring heat through this medium. In a solid, lattice vibrations mediate heat transfer. One has atoms that are organized in a periodic arrangement, and those atoms, as they vibrate, act to transfer heat between themselves. In a metal, the motion of electrons throughout that solid can also act to assist heat transfer. A second mechanism that we can consider is that of convection. This is heat flow assisted by fluid motion. Imagine you're feeling hot and you turn on a fan. That fan acts to convect air across our skin. At the microscopic level, heat transfer from our skin to the air is done by conduction because there is a no-slip condition at that interface. What this means is that as heat transfers from our skin into the air, the purpose of convection is to replace that warm air mass with a cooler air mass. And that exchange then acts to give us more driving force for heat transfer and helps us dump more heat and thereby feel cooler. A third mechanism we can consider is that of radiation. This is heat flow mediated by electromagnetic radiation. These are photons moving, for instance, from the hot sun to the cooler earth. Any object with a temperature above absolute zero will emit electromagnetic radiation, and this means that there is radiative heat transfer. This is the only mode of heat transfer that can occur through a vacuum. In the case of the sun and the earth, this radiative heat transfer is responsible for the fact that Earth is habitable at a reasonable temperature.